Greetings of the day, dear students. Today in this video we are going to discuss about the source transformation, which is a very important topic while solving the problems, right? Here by the time we complete this video, you are going to learn about the what are the different techniques to be applied. For example, here when a voltage source is there in series with a resistor, how we can simplify that, and also if there is any current source in parallel with a resistor, how to simplify that part we will see in this topic. And also we will discuss about the source transformation. Is it possible for an ideal voltage source and an ideal current source or not, right? And also we will discuss some examples on this topic, how to apply the source transformation in a detailed, simplified, step-by-step manner. Okay, yeah. Observe, for example, somewhere in the problem, sometimes we are supposed to apply these intermediate steps. We are supposed to use this source transformation technique. What it will say is, if there is any voltage source in parallel, in series with a resistor, it can be replaced with a current source in parallel with a resistor. That means here, while transforming this voltage source in series with a resistor to a current source in parallel with a resistor, now the question arises, what should be the value of current? Here, how much value of current source we have to take? That depends upon the this source voltage or this voltage across which elements we are making the transformation. That voltage is important, right? In this context, now this value of current source must be equal to V divided by R. That much value of current source we have to consider here, right? For example, here if there is some 12 volts voltage source is there and it is in series with a 6 ohm resistor, then this circuit will be same as this circuit if the value of current source is taken as V divided by R. In this context, what is the value of V? 12. 12 divided by 6. That means it is a 2 amps, and the value of resistor will not change. That will be same, equal to a 6 ohm resistor. So these two represents these two circuits are equivalent. That means they will have the same voltage current relationship at the terminals 1 and 2. Similarly, the reverse thing is also possible. For example, somewhere in the problem, if there is a current source in parallel with a resistor, you can transform it to a voltage source in series with a resistor like this. Now, while doing the transformation, what should be the value of voltage? That value is given by that value of voltage must be equal to the current that is parallel to this element, or this current value into this parallel resistor I into R, right? As this is a simple circuit, it is very easy, right? While doing the problems, you will understand how to do it in a step-by-step manner. Now, one more important point is, here I have drawn a current source. The arrowhead of the current source in the circuit diagram is I have pointed it towards up. You have to look where the polarities of the voltage source. You please place the arrow towards the positive terminal of the voltage source. We have to take the arrowhead direction towards the positive terminal of voltage source. This is important. For example, voltage sign is like this, current is negative sign is like this, right? You cannot draw like this. A current source you have drawn, value also correct, but you should not place arrow downwards, and a resistor like this. This is wrong, right? So you place the arrowhead of the current towards the positive terminal of the voltage source. That is important, right? I repeat again, current source in parallel with a resistor can be replaced by a equivalent voltage source in series with a resistor. Can be replaced with a equivalent voltage source with a resistor. Okay. Now, for example, if there is an ideal voltage source is there, what does it mean? It does not have any internal resistance, so there won't be any resistance. Its resistance are equal to 0 ohms. Then I can't say that it can be transformed into a current source like this. No, it cannot be transformed. Why? Because there is no resistor in series with the voltage source. Is there any resistor value in series with the voltage source? No. So it cannot be transformed to equivalent current source. Important, dear students. If you are having only voltage source and there is no resistor in series to the voltage source, you cannot transform it to a equivalent current source. Some R equivalent must be there. Similarly, if you are having only current source and there is no equivalent resistance across the current source, there is no equivalent resistance or parallel to the current source, then also we cannot transform it to a equivalent voltage source. Very, very important. Very, very important. Right? Yeah. Now one more important basic is, in our electrical circuits connections, you won't have something like this. We cannot make such kind of connection. Two voltage sources, one is of 6 volts and other is of positive negative 12 volts. No, if there are two voltage sources connected in parallel, their voltage value must be same. This is wrong. But you can make a connection like this, some positive negative and some positive negative, and here it is 6 volts and it is 12 volts, and this one you can replace it with a and B. You can replace it with a single voltage source, no problem. This is okay. How much it will be across? Because two different values of voltage sources in series, it is valid. Positive, negative, it will be around 18 volts. This is valid. But observe, two voltage sources which are of different voltages connected in parallel. Now you cannot say that I will draw it into a single voltage source. Not possible. In parallel connection, the basic is voltages must be same. Voltages must be same. This is wrong. Right? Similarly, you can now guess for the current source. Observe, somewhere you have seen like this. One current source is there, current source 1, which is of 5 amps, and there is another current source which is of 2 amperes. One more current source, 2 amperes, right, across A, B. Now you can take it into a single current source of value, right? This is a single current source of value 5 plus 2, 7 amperes. Nothing wrong. A and B. As two arrowheads are in the same direction, I have taken 5 plus 2. If this 2 amps arrow direction is like this, then I might have taken 5 minus 2, right? As the two arrowheads are in the same direction, 5 and 2 I have added up at this point. Up to here 5 amps is coming, and 5 amps is coming. Up to here some 2 amps at this point, and the equivalent I can take it as 7 amperes, right? Now similarly, now which is not valid with respect to the current sources, you cannot say something like this, sir, there is one current source like this, here it is 5 amperes, and there is one more current source like this which is of 2 amperes. Of course such kind of connection we won't make. A, B, and you can't say it is equivalent to, you can't say this is equivalent to a current source like this. 5 and 2 are in series, 5 plus 2, 7. This is absolutely wrong. 5 plus 2. So dear students, these two basics are very, very important. if the voltage sources are in parallel, voltage must be same, right? If the current sources are in series, then the current value must be same. Two different voltage sources of different values in parallel connection, not possible. If two voltage sources of different values connected in series like this, 6 plus 12, you can add up. Similarly here also, current sources, two current sources of different values in parallel, you can add up and make it into a one single current value, right? So, and based on this we will solve the some of the problems. So far clear? Now dear students, please let me calculate. While applying the source transformation theorem, dear students, please keep in mind step by step redrawing the circuit is important. At last you should not simply draw the or show the final answer. You have to elaborate the steps, because in source transformation you will get more number, you have to redraw the circuit more number of times based upon the simplification you are doing in each step, right? In this problem he is asking to find the current I3, and also is specifying to apply source transformation, and also we are asked to apply what? Source transformation. So what does it mean? Whatever the circuit is there up to this part, from here to here, this entire part is to be brought up into either a single voltage source in series with a resistor, and there we can connect our remaining part, this R3 or into a single current source in parallel with a resistor. After you brought this equivalent circuit, now at the terminals of this A and B we can connect our R3, that is the meaning. So here once you brought this equivalent, now we can connect R3 like this. This is R3, and then you can find out the current I3. Or you can bring an equivalent circuit like this, and there at the terminals we can connect our R3 and we can find out the I3. So that is what mean by applying the or using the source transformation. That means in this problem these voltage source, current source and R1, R2 are to be simplified in such a manner. At last you should get a voltage source in series with a resistor or a current source in parallel with a resistor. Once you brought the equivalent circuit, then you can add or we can add our R3 resistor at the end of the terminals. And now for example, once you know this current, and if you are asked I3, easily you can apply current division rule and calculate the I3, right? Yeah. Now let me simplify. First observe, here on looking into the problem itself, we are confident enough that this voltage source is in series with the resistor Vs in series with R1. So from current source transformation, what we can do, this voltage source can be replaced with a current source in parallel with the resistor, and you redraw the circuit. This part we are simplifying, and in the place of this voltage source in series with resistor, we've got this part, and you should add this part to the remaining part of the circuit. You don't change the remaining part. We just simplified voltage source in series with the resistor, and this voltage source in series with the resistor is replaced with a current source in parallel with the resistor. That is the step 1. Now the question arises, what should be the value of current? How this 1 amp came? Yes, the value of current must be Vs divided by this voltage value, Vs divided by this resistor value, Vs divided by R1. So 1 ampere. That is the reason we have taken I as 1 ampere. Resistor value please don't change. We don't need to change the resistor value. So far clear? That is step 1. This is all based on looking into the circuit only. Okay. Now observe. After redrawing the circuit, on looking at this circuit we are getting some idea. Now this is the circuit we have to solve now. That part is completed. Now this one is to be simplified further. If you observe, this I 1 ampere and 5 amperes are in parallel. This 1 ampere and 5 amperes are in parallel. If you observe, both the arrowheads are towards upward. This is I1 coming like this. This is 5 amps is coming like this. So these two are in parallel. We can add these two currents into a single current value and redraw the circuit. Again, please redraw the circuit. You can ask us, sir, in between these two R1 is there? No. Okay. How you are saying these two are parallel? Observe, dear students. This is R1. This is R2. This is R3. R1, R2, R3. This is the connection. Now this is also same like this only. You can take here R1. The meaning will not change. This is R3 and this is R2. Is there any change in the meaning? No. Still all the resistors are in parallel only. Do you got the point? If there are no other further elements there. Now these two are in parallel. You just add up those values. How much you will get? Two arrowheads are in the same direction. So 5 plus 1, 6 amps in parallel with R1 and R2, and redraw the circuit. So this is further simplified to this part. Now on looking into the circuit, our target or aim is we have to simplify up to this part. Up to this part you should get simplified. Still we are having two resistors here. It should be brought up into a single resistor. Observe, R1 and R2 are in what? Parallel. Now these two resistors, which two resistors are in parallel? 10 and 20. And from the basics we know, if two resistors are connected in parallel, for example this is R1 and this is R2 across A and B. If it is 3 ohms, if it is 2 ohms, this is equivalent to a single resistor of how much? A, B. R equivalent will be how much, dear students? If you want to simplify it into a single resistor value, AB by A plus B. AB, 3 into 2 divided by 3 plus 2, that is 6 divided by 5, that is 5 ones are 5.102. So this is same as 1.2 ohms. We know this basic. Already we have discussed. If two resistors are in parallel, R equivalent will be R1 into R2 divided by R1 plus R2. Let me apply the same rule here. 10 ohms and 20 ohms are in parallel, right? So 10 into 20 divided by 10 plus 20. So we will get around 6.66 ohms. 6.66 ohms. So now what we do is, observe the previous circuit. In the place of these two resistors, we will draw only now one single resistor, that is R equivalent 6.66. So far clear? Right? Now, so we came up to here. Right? Now observe, once you know this current I1 and current flowing through this one be some now we want to find out this current division rule we have seen now. For example, if you are having some total current like this, current division rule, what it will say, if there is some I1, if you are having two resistors, if this current is IA and the resistor value is RA, and we are having one more resistor and the current value is IB and the resistor value is RB, right? So what about IB? IB equal to total current into opposite arm resistance. To find this current, you take the resistance in the opposite arm, that is opposite arm is RA divided by total resistance RA plus RB. This is what current division rule we have learnt. Very important. Already we have discussed this current division rule. if you are having a total current like this, if I1 is flowing like this, it is divided into two parts, IA and IB. Then if you want IB, you should multiply total current I1 into opposite resistance RA divided by RA plus RB. Similarly, observe, dear students, now I want I3. Now tell the formula. I3 equal to, what is the total current entering here? I1. This current is I1. I1 into, for this I3, what is the opposite side resistance? This R equivalent. So R equivalent divided by, what is the total resistance? This R equivalent plus R3. R equivalent plus R3. This step is very important. Even though you have simplified up to here, if we don't know the current division rule, then the entire problem goes wrong. This I3 equal to total current into opposite arm. Total current into opposite arm resistance divided by total resistance. If it is voltage division rule, total voltage into same arm ARM, same arm resistance by total resistance, right? So that is what we have done here. 6 into 6.66 by total resistance, 1.09 amps. So now I3 is how much, dear students? 1.03, 1.09 amps. Very important. So while doing the problems on the source transformation, you have to draw the more number of times. You have to redraw the circuit. Whatever the previous step you have simplified, you have to show it in the form of a diagram in the next step. What simplification you have done, that is to be visible. So it's not something that only for final answer you will get the full marks. For the procedure and steps, you will be awarded the marks. Every time you are doing the transformation, either for voltage sources or current sources or for resistors, you please indicate that step clearly and redraw the circuit. That is where you will get the marks. You redraw the circuit, indicate the current directions, indicate the voltage polarities, write the formulas, do the substitutions. That should be visible in the paper. Then that helps you. Not for all the full marks only for this 1.09 amps. No, it is not like that. Right? Procedure is important, dear students. Next, let me see the one more example. See here, apply source transformation across AB. That means its meaning is up to this point you have to simplify the circuit. Whatever elements are there up to AB, you have to look into the circuit. From this side you look into the circuit. So how many elements are there? 4. You bring it into simplified form. Either one voltage source, anything is okay. Either you can bring it into a single voltage source in series with a resistor up to that part, or you can bring it into a single current source in parallel with a resistor. Anything is correct only. You can bring it to a single current source in parallel with a resistor or a single voltage source in series with a resistor up to this part. Now on looking into this, the first thought you will get is, sir, this 4 ohms and this 4 ohms are in parallel. Let me simplify. 4 ohms, replace it with a single resistor. That single resistor value will be how much? 2 equal resistors, 4 and 4 are in parallel. We know the formula for equivalent resistors. Equivalent resistance when 2 are in parallel, R1 R2 by R1 plus R2. 4 into 4 divided by 4 plus 4, 16 by 8, you will get 2 ohms. So we can replace these two resistors with single resistance of 2 ohms. Clear? Now observe these two current sources. One is like this. One arrow is pointing towards up and the 2 amps is pointing towards down. Now your I equivalent will be how much? 5 minus 2. 5 minus 2. And once you got this value of 3 ohms, every people will find out the 3 amps correctly only. But whether the arrow should be placed upwards like this or the arrow should be placed like this, which one is correct? Yeah, you have taken the 5 minus 2. So this one is correct. The 5 amps direction you take it as a reference. Upwards resultant value towards 5 amps. This is wrong. Magnitude wise correct only, but inside the circle the arrow should be upwards or downwards. That is also important, dear students. This is where most of the students will commit the mistake once again. And some people in the hurry manner, what they will do is they will see 5 amps is there, 2 amps is there, both are in parallel. What they will do is 5 plus 2 they will do 5 plus 2 7 amps they will say, and they will simply draw a circle like this, and they will place a arrow upwards like this, and here they will indicate as 7 amps, and they will think the problem is correct, but wrong. This is also wrong. Why? Because here 5 amps is upwards and 2 amps is downwards, so it is not 5 plus 2, right? So this is also one possibility where students can commit mistake. Even though the problem is simple, you may not get the answer. Okay, yeah. So what I want to say is 5 amps, 2 amps, and equivalent is how much, dear students? 3 amps. You place the arrowhead direction in the direction of 5 amps. Clear? Right. Don't think that these two are parallel. 5 plus 2 is 7 and 7 is the correct answer. Then that is wrong. If 2 amps direction is also upwards, then you are correct. If 2 amps is also pointing upwards, then 5 plus 2, that is correct only, 7 amps. But both the directions, arrowhead directions, are in opposite to one another. Right? Yeah. So this is what I have written here. That is the precaution you have to take. Now finally we got 3 amps, and equivalent resistance also we have found out, and finally we got here 3 amps, and the equivalent resistance is 2 amps. Now observe, this current source is in parallel with the resistor. This can be transformed to a single voltage source in series with the resistor, but this value of voltage must be how much? It must be equal to the, it will be equal to the I into R. This value must be equal to the I equivalent into R equivalent. In this context, I equivalent is 3, R equivalent is 2, so 6 volts. So this circuit is also same as 6 volts. Arrow is pointing upwards, so upwards you indicate positive, downwards you indicate negative, and this is R equivalent. It will not change, it remains same. That value is 2 ohms only. Both the circuits are correct only. Both the circuits are correct only. Okay, dear students, these are the important basics, and once again I will tell you, this 2 voltage sources of different value. For example, 5 volts, 3 volts. Okay, you cannot get it into a single equivalent voltage source. This is wrong. But if you have some 5 volts and 3 volts, okay, then you can make it into a single voltage source. If they are in series, then 8 volts. This is correct. Similarly, for current sources also, you cannot say something like this. So this is 5 amps, and this is 2 amps, and its equivalent is something like this, 7 amps. Wrong. This is also wrong. Okay, so if you are having 2 current sources in parallel, I will show you these basics. You please keep in mind. And if 2 resistors are in parallel, that is important. One more basic. What is the other important basic, dear students? If 2 resistors are in parallel, immediately you get the thought to the mind. R equivalent will be R1 into R2 divided by R1 plus R2, and the current division rule. If you want to find out I2, okay, for example, then opposite side resistance, total current is I into opposite arm. Opposite arm is R1 divided by R1 plus R2 you have to take. If you are finding I1 and the total current is I, then you should multiply it with opposite side resistance, R2 divided by R1 plus R2. If it is a voltage division rule, V1 equal to total voltage into same resistance, R1 by R1 plus R2. If it is V2, other side voltage, V2, then total voltage into same resistance R2 by R1 plus R2. So these are all the important basics which makes you to solve the problems, right? Voltage division rule, current division rule, resistors in series and parallel, and voltage sources in series and parallel. Okay, thank you.